Hi, in the following series of lectures, we shall look at kinematics equations and their applications. So now first, let's learn to derive the equations. Here we see a vt graph, the initial velocity is u and the final velocity is v. So the gradient, which is the acceleration, can be calculated by the change in v, which is v minus u, over the change in t, which is simply t. And if we manipulate this equation, we will derive our first equation, which is v equals to u plus at. And now for the second equation, we are trying to find out S, which is the area under the graph of a VT graph, and this can be calculated by half multiplied by the sum of the parallel sides, which is u plus v multiplied by t, because that's the area of a trapezium. So here we have derived our second equation. And now moving on to the third, we have S equals to half u plus v multiplied by t, and in the first equation we have established that v equals to u plus at. So we substitute that in, and here we get our third equation, which is S equals to ut plus half at squared. And now moving on to the last equation, for v equals to u plus at, if we try to make t the subject, we get t equals to v minus u over a. And now we shall try to substitute this into S equals to half multiplied by u plus v times t, and we get our fourth equation, which is v squared equals to u squared plus 2as. So here is a recap of the four equations which you need to know how to derive.